Hello, welcome to another module in this massive open online course. So, we are looking at example problems for the Z transform. Let us continue this discussion. So, we are looking at example problems pertaining to the Z transform and the properties of the Z transform. Okay, and from our previous discussion what we have seen is that we are evaluating the inverse Z transform, and we have seen that xz is basically given by this expression, that is z over z minus 2 minus 2z over z minus 3 plus z over z minus 3 square. So, let me just write it down. So, xz in the problem that we have done so far is z over z minus 2 minus twice z over z minus 3 minus twice z over z minus 3 plus z over z minus 3 square. So, we have 2 less than magnitude of z less than 3. Okay. And now, in this we know that, for instance, z over z minus 2, this corresponds to, so if you look at this term, z over z minus 2. Now, remember, now look at this, the ROC corresponds to magnitude z greater than 2. So, this is a right handed signal with respect to the pole at 2. So, the inverse Z transform of z over z minus 2 is 2 raised to n u n. So, this has inverse Z transform 2 raised to n u n. Now, minus 2 minus 2z over z minus 3. Now, this has inverse transform. Now, this is inverse z, this is minus 2. Now, remember the ROC is magnitude z is less than 3. So, this is a left handed signal with respect to the pole at 3. So, the inverse Z transform of this is minus 2 times minus 3 raised to n u minus n minus 1. So, this is equal to basically twice into 3 raised to n u minus n minus 1. Since the ROC is basically magnitude z less than 3, that is 2 less than magnitude z less than 3, correct. The inverse Z transform of z over z minus 3 is minus 3 raised to n u of minus n minus 1. Okay. Now, we come to the remaining term, that is the term which is of the form z over z minus 3 square. Consider now z over z minus 3 square. Consider now the term z over z minus 3 square. Now, to evaluate this, we use the property to evaluate the inverse Z transform. We use the property following property: minus z d over z dz x tilde z, that is, if you differentiate the Z transform, that corresponds to the sequence n x tilde of n, that is the sequence, or that is the signal n x tilde n has Z transform minus z d over dz, that is the derivative of x tilde z. X tilde z, remember, is the Z transform of x tilde n, that is x tilde n has the Z transform x tilde c. Now consider z over z minus 3. Now let us say x tilde of z, okay, just to denote it by different notation, equals z over z minus 3. Okay. Now d of, now differentiating this, d over dz of x tilde z equals the derivative of z over z minus 3 equals the derivative z minus 3 plus 3 by z minus 3 equals the derivative of 1 plus 3 over z minus 3. Now, if you take the derivative of this, you will realize that this is basically nothing but the derivative of 1 is 0, what is remaining is minus 3 over z minus 3 whole square. So, this is your basically d over dz of x tilde of z. Now, minus z d over dz of x tilde z is minus z into minus 3 by z minus 3 whole square. This is basically 3z by z minus 3 whole square. So, what we have is basically, what we finally have is basically 3z by z minus 3 whole square, that is minus, remember 3z by z minus 3 whole square is this quantity minus z d over dz, that is the derivative of x tilde z. Okay. And therefore, this corresponds, the inverse z transform of this would be n x tilde n, where x tilde n is the inverse z transform of x tilde z. Remember, this corresponds to x tilde n corresponding to z over z minus 3. This is equal to, remember, minus 3 raised to n u minus n minus 1. So, this will be n. So, this will be n minus 3 raised to n u minus n minus 1 equals minus n 3 raised to n u of minus n minus 1. Okay. That is 3z over z minus 3 square, which implies that basically z over z minus 3 whole square will therefore have the inverse z transform minus z, bringing the 3 onto the right side and dividing it, minus n 3 raised to n minus 1 u minus n minus 1. So, that is the inverse z transform of z over z minus 3 square, that is minus n 3 raised to n minus 1 u of minus n minus 1. That is the inverse z transform of z over z minus 3 square, corresponding to, of course, the ROC 2 less than magnitude z less than 3. Okay. And therefore, the final inverse z transform, basically we put together all the terms to get the final inverse z transform, that will be x n equals 2 to the 2 raised to n u n plus 2 into 3 raised to n u of minus n minus 1 minus n into 3 raised to n minus 1 u of minus n minus 1. This is the inverse z transform. This is the inverse z transform of the given function. Okay. So, this is the inverse z transform. So, we have constructed the inverse z transform of this rational function. Remember, we started with a rational function of z which has a multiple pole corresponding to which has a pole of multiplicity greater than 1, pole of multiplicity 2 at z equal to 3, alright, and that is basically the inverse z transform, which we basically derived using the first constructing the partial fraction expansion and then constructing the inverse z transform of each of the terms in the partial fraction expansion. Okay. Let us look at another example. Now, consider the system with impulse response we have the impulse response Hn equals An Un is positive and less than 1. Okay. Now, consider the input xn, that is the unit step function. Now, this is given as the input. Now, this is the input. Okay. So, this is basically the input. Now, we have to find the output, using the z transform. Find the output using the z transform. Now, this can be solved as follows. So, let us look at the solution. So, we have the z transform, remember h of n equals An Un. The z transform of this is h of z equals z over z minus a. The ROC is magnitude of z greater than a, alright. This is z transform of the input An Un, which is a right sided signal. The z transform of this is z over z minus a. Okay. Now, let us look at xn. Xn equals simply Un, and therefore, the z transform of this is Hz equals z over z minus 1. Now, Yz, remember z transform of the output. Now, remember we know Yn is simply the convolution Hn convolved with Xn, which implies the z transform Yz equals Hz into Xz. This is the z transform. This is z transform of the output, which is Hz times Xz. So, this is basically your z over z minus a times z over z minus 1. This is z square divided by z minus 1 into z minus a, and the z transform of this. Now, remember the ROC of this is basically magnitude of z greater than 1. Previously, we had magnitude of z greater than a. So, you combine both these things. Now, since a is less than 1, so now the ROC basically has to include both, has to be basically both magnitude z greater than 1 and magnitude z greater than a. Now, since a is less than 1, correct, the magnitude z, so this has to be the intersection of these two regions. So, the z trans, so the net ROC will simply be magnitude of z is greater than 1. So, the net ROC is simply magnitude of z. So, you can also see this, the ROC is intersection of magnitude z greater than a intersection with magnitude z greater than 1, which is equal to magnitude of z greater than 1 since a is less than 1. Okay. Now, if you look at y z, now we have y z equals z square by z minus 1 into z minus a. So, y z over z, that is equal to z over z minus 1 into z minus a, which I can express as, naturally I can express this as c 1 by z minus 1 plus c 2 by z minus a. Now, what is c 1? The coefficient c 1 is, well, z minus 1 into y z over z evaluated at z equal to 1, which is basically z over z minus a evaluated at z equal to 1, that is 1 by 1 minus a. So, c 1 is basically 1 by 1 minus a. Now, how about c 2? C 2 is well, basically coefficient corresponding to the term z minus a, correct. So, that is z minus a times y z over z evaluated at z equal to a. So, this is basically your what this is basically your z over z minus 1 evaluated at z equal to a, which is basically your a over a minus 1, or this is basically minus a over 1 minus a. Okay. And therefore, what we have is basically we have y z equals, now c 1 is basically your 1 over 1 minus a. So, this is 1 over 1 minus a z over z minus 1 plus a over a minus 1 into z over z minus a. Now, one can take the inverse z transform, you get y n equals 1 over 1 minus a. Now, of course, consider, remember the ROC is still magnitude of z greater than 1, which means this is a right handed signal. This is a right handed signal. So, this is 1 over 1 minus a z over z minus 1 inverse transform, inverse z transform is u n minus a over 1 minus a inverse z transform of z over z minus a is a n u n, and therefore, combine these two, what you get is 1 minus e raised to n plus 1 divided by 1 minus a into a to u 1. This is therefore the output, which we have now evaluated by using the z transform. This is the output signal y n. Which we have evaluated, remember, using the z transform technique. All right. So, we have given an input signal, we were given the impulse response, which is I think if you look at the impulse response is a raised to n u n, correct, and you are given the unit step signal as the input, that is x n equals u n, and we are asked to find what is the output, and we have demonstrated using the z transform technique that is that the output is 1 minus a raised to n plus 1 over 1 minus a times u n. Okay. So, that is the output of this system. Okay. All right. Let us continue to another example, example number 8. The step response. Now, here we are given that step response the step response of an LTI system equals a raised to n u n. Now, what we have to find is basically we have to find what is the impulse response. What is the impulse response of this system, that is what is h of n for this LTI system. Now, remember what we know is if the input is x n, we are given the unit step response, that is if the input is x n, which implies x z equals z over z minus 1, correct. Magnitude of z is greater than 1, that is the ROC, correct. This is the input, remember. This is the input. Now, output is y n equals a raised to n u n, y z equals z over, this is the output. Okay. This is the output. Now, therefore, the transfer function h of z, remember this is given as y z over x z. Okay. So, this is the ROC, of course, again ROC is magnitude z greater than a. Now, the ROC of both will be magnitude, once again ROC will be magnitude of z greater than 1, since a is less than 1. Okay. And therefore, this is y z over x z, and y z over x z you can clearly see this is z minus 1 divided by z minus a. Okay. And this is basically your h of z. This is the transfer function. Remember what is this? This is your transfer function. This is the transfer function for the LTI system. Okay. And therefore, now I can, now if I look at h of z over z, that can be expressed as z minus 1 over z into z. So, there are two poles, z equal to 0 comma a naturally. So, I can express this as c 1 over z plus c 2 over z minus a. Now, the coefficient c 1 corresponding to z is c 1 equals z times h z over z evaluated at z equal to 0, which is basically z minus 1 over z minus a evaluated at z equal to 0, which is basically your 1 over a. Okay. Now, C 2 equals z minus a into h z over z evaluated at z equals a, which is basically your this will be z minus 1 over z evaluated at z equal to a, which is a minus 1 over a, or which is basically also minus of 1 minus a over a, that is your coefficient C 2. So, therefore, what we have is now h z over z is, well, 1 over a into 1 over z minus 1 minus a over a into 1 over z minus a. Now, for a right handed signal we know, now we know 1 over z, this impulse transform, now this impulse this is corresponds to the delta function, inverse z transform is delta n, 1 over z minus a, this is a raised to n u n, and therefore, and now of course, this is basically, now of course, this is h of z over this is h of z over z, correct. Now, let me just correct this. So, now we consider h of z equals 1 over a minus 1 minus a divided by z over z. So, 1 over a, now this corresponds to 1 over inverse z transform is 1 over a times delta n, and the inverse z transform of this is 1 minus a divided by a raised to n u n. So, therefore, what we have is h of n. Now, if you take the inverse z transform, h of n is 1 over a delta n minus 1 minus a minus 1 minus a over a raised to n u n. Okay. Now, let us evaluate h of 0. Okay. H of 0 is basically delta of 0 is 1 over a minus 1 minus a over a raised to n, a raised to 0 is 1. So, this is 1 minus. So, this is basically simply a over a equals 1. So, h of 0 is 1, and h of any n greater than 1 equals, of course, delta n for n greater than 0 is 0, for any n greater than 0, h of n is simply 0 minus 1 over a raised to n, which is basically minus 1 over a raised to n minus 1. Now, this is for n greater than 0, and therefore, combining both we have naturally h of n at n equal to 0, it is delta n minus 1 over a into a raised to n minus 1 u n minus 1, that is, this is for n greater than 0, or you can say n greater than or equal to 1. So, this is 1 minus 1 over minus 1 minus a raised to n minus 1 u n minus 1. So, this is the impulse response of the this is the impulse response of the system. All right. So, we have started with a system in which the step response is given, correct. The step response, that is the response to the step function u n, is a raised to n u n, and we are asked to find the impulse response. We have found the impulse response of this system using the z transform technique. We have shown that the impulse response is delta n minus 1 minus a into a raised to n minus 1 u n minus 1. All right. So, this is the impulse response h n of the system. All right. So, we will stop here and look at other examples and continue with other aspects in the subsequent modules. Thank you very much.